All right, final version number 2 using the hash table. Let me remind you very quickly before I start coding. This is the extra tutorial I mentioned before about the basics about array list and also hash map. Hash map is just another variant of hash table. So whatever you learn from the hash map, you can definitely apply that to hash table and vice versa. Okay, you should really go over the hash map. So there's certain basics basic operation which I wouldn't explain in the current tutorial video. I will rely on you to actually look at this extra one as well. So that'll be actually more complete for your learning. Okay. Let me now go back to our current project over here. Before I start coding for the version number 2, let me now write a JUnit test, right? Remember, every time before you actually start coding, you should really try to write down some test cases, test-driven developments. So here, this is version 2 that we want to fill in a moment. Let's now go to test birthday book. So this is test number 1 that was working. So let me just copy the entire test. Don't forget, you also need to also copy the add test. Otherwise, you wouldn't be treated as a test method. Okay, copy that and paste it over here. So it will be test number 2. And the only thing I want you to change will be, rather than birthday book version 1, is going to be version 2 using the hash table. Okay, version 2. Just don't forget, right? Otherwise, you might just be testing the same thing as before, right? At the moment, if I simply try to run the JUnit test, you can see that test number 1, which we did previously using the array list, is working. But for test number 2, using the hash table, we haven't done that yet, but we'll eventually want to make it green. Let's now close the test case. Let's now just focus on coding that. Okay, you might find that the visualization that we did for the array list is actually a little bit complicated, but I wouldn't say it's really complicated. It's just the different nature of the collection that we are using. So let me just tell you the essence about array list implementation, so we can make it it's actually a more natural concept when we talk about hash table. So really, the intermediate level of objects over here is about the birthday book entry, right? So every store in as every element in the array list is actually a birthday book entry containing the name and also the birthday object over here. However, in the case of the hash table, we don't really need this particular extra level. We don't need to define that ourselves, and also when we visualize it, it will be much neater to actually visualize the application. It doesn't really suggest that you should always use a hash table as opposed to array list. It really depends on the application. So you should really learn both, and also you should be able to visualize in both cases. Okay, let me say it again. In the case of hash table, you will see that we don't really need to talk about this concept over here explicitly. It's simply just included. I'll show you to you. Let's now go back to Eclipse, and then we're just going to declare, like in version number 1, so which library class do we want to use for the attribute type hash table. So what we'll do is we're going to say private over here, and then hash, and then control space, and you can choose hash table. Okay, you can see hash table. Notice that it's actually the hash table from Java.utility package, right? And then, so we got 2 generic parameters. So I'm going to include the links for the relevant lectures explaining about what generic parameters really mean briefly, and also about how you can instantiate them. So for the current tutorial, I will assume you already watched that lectures and also extra tutorial. Okay. So now in our case, let's see some connection over here. In the array list case, we actually see the name for every entry. The name is simply, so every entry over here, you can think about whenever we want to search for a particular entry, we use the name. So name is really like the keys. And also birthday is really like the value, right? So we got name being the key and also the birthday being the value, okay? And in the case of a hash table, it's like a 2-column table. I'll visualize that in a moment. But for the hash table, we just need to instantiate the types for the key and the value. So in this case, key will just be the string for the name, and the values will be the birthday. I will show you one connection in just a moment. And then let's say this will be also imp over here, right? So that's our declaration for attributes. Let me show you right away. Recall that we actually declared this particular class called BirthdayBook entry over here. You can see the BirthdayBook entry is only applicable for version number 1 where we want to use the array list. Now in this case, we got name and also birthday, right? You can see string and also birthday. But now in the case of the hash table, we got string and also birthday over here. So it's somehow encoded inside the hash table concept. Okay. All right. What about constructor? We want an empty birthday book. Let me maximize it. So let's see how we can initialize an empty hash table. Imp is assigned to new, and if you say control space, you can see we got some auto completion here, just like that. Okay. So this part over here, you can simply leave it as empty. Java compiler will be clever enough to figure out you really meant to write string and birthday over here. So that's fine. Okay. You can also alternatively also put string and birthday over here. It would be fine too. And here you can see there's no arguments over here, just to create an empty birthday book. Okay. Empty hash table internally. How do we get the size? That one should be as easy as version 1. So we can simply say return this.imp.size, right? The number of entries. So the fundamental concept for a hash table is it simply stores a collection of entries. Each entry actually stores the key and also the value. Okay, we'll see that more vividly when I visualize it. Okay, maybe I can simply say this whenever I can. All right, how do we get a birthday? Right? In the case of the array list, we actually needed a loop. Right? You can review that code over there. But for now, we don't need a loop anymore. All we do is we can say return this.imp, which is a table, and then we can say get. And whatever you want to get something. You want to get a value that's associated with the key. So now the key will just be the name. That's all we need to do. You can see it's only a one-line implementation. You can think about ultimately there should still be a loop somewhere. However, in the case of the array list implementation, we have to do the loop. However, in the case of hash table, the developer of the hash table already did some searches inside the get method, which is hidden from us. We don't need to do it. Okay. And then let's say, how do we add a birthday? We basically want to add a new entry. So all we got to do is this.imp.put, right? So when you say put, you want to put the key and the value. A pair of key and value will make an entry. So in this case, it would be the name over here and also the birthday over here, right? So one thing to note, you can see the name over here, string, actually matches the string over here, and also the birthday second argument here, second parameter, also matches the second generic parameter over here, right? Notice the difference. Notice the connection, correspondence. So now we're also done with the add birthday. What about remove birthday? Do we have a remove method? Yes, we do. So we can say this.remove, this.imp, right? The hash table dot remove. And then you can see we can use the version where we simply want to remove the entry that has its key being the input key, right? So remove, and then we simply pass the name. Right? You can see in the case of the hash table, where the entry concept is more fundamental than is more supported by hash table than is supported by array list. So that's why we saved so many lines of code to be written. But again, it depends on what you need. If you need an application more like a birthday book, maybe hash table will be a better choice. But in other cases, maybe array list will be a better choice. So that's why you should really know the essence for both versions. Finally, how do we do remind? So I would say this one, unavoidably, we have to use a loop, right? We have to go over the entries in the hash table one by one. And then for every entry, we want to see what's the corresponding birthday. If that corresponding birthday matches the input birthday, and then we should really collect the name. Collect the name from the for that particular entry. So I think unavoidably, we still need a loop, right? Let's now program this very quickly from scratch, right? It's good review for that particular pattern. So what I would say is, I'm going to say here, I will use something very similar to, you know what? We should be able to copy some code from before, so to save some typing. Let's go back to V1 over here. Okay, let's go back to the remind. Why don't we just copy this fragment of code? I'll tell you which part to change in a moment. So that's from version number 1, and copy the remind method implementation, and simply paste it over here. So this part, we still need a temporary array. We still need it. We still need a counter. Okay. And now, how do we go over So this imp that we just copy over from version number 1 is actually an array list. So the way we actually go over entry by entry is by using the the indices, right? But now for hash table, there are 2 ways for you to actually go over the hash table. I'm going to show you one way by using the key set. The other way by using entry like another library class from Java collection. I'll leave you to actually study this extra tutorial video. Let me emphasize that. So I should really let you do some self-study as well. So if you go on to study this particular video, it will show you the second approach of using the entry. I'll show you the first approach. All right, let's now go back here. So the way for me to go over the entry, using the key set will be something like this. So we're going to use the so-called for each loop. So I'm going to say this imp dot key set. So it's simply just going to return all the names that's currently stored in the hash table, and then each one of them is going to be of type string, right? You can see here the key type is actually string. So I can say here for each loop, you can see the more detail about this notation here in the extra tutorial video. So I can say string and then name and colon over here. And as I said in the extra tutorial video, the colon here is actually corresponding to the set membership operator that you actually learned in your math, maybe 1019 or 1090 course about discrete math, right? Just some notes over here. So we are saying that we're going to go over the strings in the key set one by one. Every one of them is going to have this local name called name, okay? And then once we got a name over here, we're just going to get a birthday, right? So how can we get a birthday? So the way to get a birthday will be, we can simply say this imp. How do we get a corresponding entry, corresponding birthday given the name? Well, just saying get and then name over here, right? So this will be the birthday. And then we want to check to see the same way as before. We want to check to see whether you got the matching month and also matching day. And then if they do match, we want to get a corresponding name. And the name, we know them already, is simply just name over here, right? And the rest will just be the same. All right, guys, I'm doing that. I'm trying to do that in a way that I really want to compare the 2 versions of implementation rather than doing that from scratch. Hopefully, that will help you. All right. So now we're done with the implementation for hash map, the hash table. Let's now go back to the JUnit test and see if everything runs. And then if it does, we're gonna do some tracing. Let's now go back to test birthday book over here. And we're now hoping that test number 2 will also work. Let's now run the JUnit test. So now this is not passing. Let's see why. So it's now line. If you see under failure trace, if you go to line 84, okay, 84 over here. So we are failing this particular one here. Let's see why. Okay. So if I put a breakpoint over there, and then I will launch the debugger, and then switch to the debug perspective. Actually, you know what? Let me. I just need to remove the previous breakpoint. Let me start again, and then launch the debugger. All right. So now I'm right here. Okay, right here. Actually, there's another breakpoint I want to remove. Sorry about that. Let me stop, and then launch the debugger once more. Okay, 84. So now somehow these 2 are not really matching. Let's see why. So we got reminders 1. What's reminders 1? Reminders 1 is actually Tom and Mark. Ah, I see. Okay, so this is something really worth noting, right? This error over here. In the if you just rewind back to the second video for this week, when I try to set up the JUnit test, I actually mentioned before for this particular array. So in the case of hash table, it may not actually follow this particular order. Let me give you a quick reason. But for the exact reason, you have to wait until your second year. In the case of the hash table, we say that the collection of entries are not really ordered. There's no ordering amount the entries in the hash table. On the other hand, in the array list, we definitely got the order, right? Index 0, index 1, index 2. But in the case of hash table, whenever we want to get something from, especially you can see here, if I go back to the remind method over here, when I say I want to go over the name one by one from the key set, there is no guarantee about the order in which they're going to return the name back to us. We would think it's going to give us, according to the order in which we added the birthday book entries, Alan, Mark, Tom, and Jim, we would hope. But somehow the internal implementation for the Java library hash table does not give us that order. But in this case, you still give us Tom and Mark, but not really in the order that we expected, right? So how can we fix this? I would say, since we know for this particular test case, the hash table is actually going to return back to us Tom, Mark, rather than Mark, Tom. So the easiest fix would be we can simply change in the test case, right? Let me just stop this. Okay, so rather than Mark Tom, we can actually say Tom Mark. Okay, so this might be the easiest way to fix it, but I'll write some comments here. Another way to do it is you can write you can write a helper method in the current JUnit class, which will actually try to compare if the two arrays are the permutations of each other, which means they are equal in terms of their contents despite the ordering. But that would be a little bit too complicated for now. So I would say if you're really curious about how to make this work, try it out exactly what I just described, the helper method, checking that if the two arrays are permutations of each other, and you can use the helper method here to check rather than array equals. Because when you use assert array equals, it has to be index 0 equal to index 0, index 1 equals index 1, right? Okay, so I changed the order. Let me now go back to run the test again. And now I got a green bar. Okay, let me document it quickly. Okay. In the case of hash table, the order in which key set return string is unpredictable. So now that's why in this case we just learned that it's actually Tom Mark as opposed to Mark Tom, but the contents are really the same. So I think we can tolerate that. Actually, that's fine. For the purpose of this particular example, I think we're okay. All right. So guys, that's about the second version over here of using hash table. I think we just modified this test case a little bit without compromising its correctness check. And you can definitely go over the code. You can see for the case of version 2, using hash table is actually much neater. But it doesn't really mean Arraylist implementation is bad. It's just that the concept about entry is supported directly by the hash table.